f of x is equal to an multiplied by x raised to n plus an minus 1 multiplied by x raised to n minus 1 and so on up to a0. We will begin by making a few observations. So, how many variables do we see here? We see only one variable x. So we can say that f of x is a function in x. We notice that x terms are raised to unique powers. So why do we use the word unique? This is because no two terms of x have the same power. Yes, we notice that every x term is raised to a unique power, but what is the power of x in the term a0? To answer this question, we need to understand that a0 is nothing but a0 multiplied by x raised to 0. So the power of the x term is 0. So we can say that the x terms have non-negative integral powers. So x can be raised to positive integers or 0. Also, every term of x has a coefficient. The coefficients are a0, a1, a2 and so on up to an. These are all real coefficients. Now, in what order do we write the terms? Should the terms be written in increasing or decreasing powers of x? Both the ways are mathematically correct since they result in the same function. In our video, we have chosen to write the function in the order of decreasing powers of x. Writing the terms in descending order of power is called the standard form. Now, what's the degree of a polynomial function? Can we say that the degree of a function is n? This happens when the highest power of x is n and the coefficient of x raised to n, an, is not equal to 0. What happens when an is equal to 0? Then the term an multiplied by x raised to n would be 0, making the degree of the polynomial n minus 1. So we know what the degree of a polynomial is. Now we look closely at the terms to understand the anatomy of our polynomial function. Here is our polynomial function f of x. An is the leading coefficient. This is because it's the coefficient of the x term with the highest power n. Can you guess what the terms a0, a1 times x and times x squared are called? They are called the constant term, the linear term and the quadratic term respectively. This is because the power of x in each of these terms is 0, 1 and 2 respectively. Now let's test our understanding to see if the following functions are polynomial functions or not. Is f in brackets x equal to 5 a polynomial function? Yes, it's a polynomial function of degree 0. This is because 5 can be written as 5 multiplied by x raised to 0. Here, the highest degree of the function is 0. What about these two functions? F of x equal to 2 multiplied by x raised to 4 over 5 plus 2. and the function f of x is equal to 6 over x squared? Are they polynomial functions or not? They are both not polynomial functions. This is because the x term in f of x is raised to a fractional power. For it to be a polynomial, the power of x can only be a non-negative integer. Similarly, in the second function, the x term in f of x is equal to a negative power. Hence, they both aren't polynomial functions. How about the function f of x is equal to x raised to 4 plus x? Is this a polynomial function? We notice that the x terms with powers 3, 2 and 0 are missing. Can we say that it's a polynomial function of degree 4? Absolutely. A polynomial function can have some x terms missing. So this discussion gave us an overview about the basic concepts of polynomial functions. In the next video, we will learn about rational functions.